Q1. The charge on outer surface will be, as it is a copper ball of radius r. So what is the charge distribution? Q1 plus Q2. So let's write some terms like 1, 2, 3. What about sigma? Sigma 1, sigma 2 equal to sigma 3, which is equal to Q1 plus Q2 by 4 pi r square. No interaction. Then force of interaction between charges. Force of interaction between point charges Q1, Q2 is, so what shall I write? 0. No interaction. The cavities will not interact. Simple. But the point charge, this Q1 will interact with this cavity. With minus Q1 it will interact. This Q2 will interact with this minus Q2. But no interaction between them. Similarly, if I ask you what is the energy of the system, here also the same method. But you should not write any interaction potential between them. So treat as if only this cavity is present and this charge, write energy. Treat as if only this is present, this Q2 is present at the center of cavity, and this charge here, then write, there'll be the final thing. Okay, this of all this is very important. Fundamentally, no interaction between the cavities, because this will act like electrostatic shield for this. If I remove this charge, okay, I'll remove this charge here. Then what about field strength at this point? Will be 0. I'll increase the charge. What about field strength here? Net field will be 0. If I remove this point charge, so what about the field? The net field inside the cavity here must be 0. Because it acts like an electrostatic shield. Okay, let me introduce one more. Suppose if there is a sphere is there, I'll immerse in an uniform electric field. There's an iron ball. There's a uniform electric field there. How the lines of force will be? Here the lines of force has to terminate like this. We know the electric lines of force should terminate okay, this will be the electric field. If I remove this sphere, only the field will be uniform. So what about the charge? Charge here will be negative charge will be induced. This will be positive charge. What about the net field at point P? It should be 0. Due to external field, E0 will be, due to external field will be like this. So this is actually uniform. This field is uniform. Later on we'll draw horizontal lines so that you'll understand. You have plenty of good questions of these kind of, please do refer, try to think on them. They're very fundamental concepts related to very fundamental. Means one question will help you to solve another 10 questions. So these are the things which are very useful. So when iron ball immersed in a uniform electric field, the lines of force will get disturbed and will be of this kind. The lines of force should terminate at negative charge, should originate at positive charge. Okay, similarly, I'll make a cavity in iron ball, then we'll see what conditions will fit. So here, let me take a I'll bring a spherical cavity inside this. And an uniform electric field is present. What about the direction? So there's a uniform electric field. What about the uniform field? Okay, this is the cavity. This is an iron block. So here a negative charge will be induced. Positive charge will be induced here. What about, I'm interested few things. So let me give 1 point P1, P2. I'm just bothered about these things. Yeah. Anybody? What should be the net field at point P1?